Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about the applications of the auxiliary planes to evaluate the true shape and size of an inclined surface of the solid. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with the orthographic front view and the top view projections of the solid, and we can observe over here in the top view we can observe an inclined edge view of a surface, and in the front view we can check that this is the apparent shape of the surface over here. So this is the T-shaped surface which we have observed in the front view on the vertical plane as an apparent view projection over here, and this surface has been represented as an edge view in the top view projections of this particular solid. Now this edge view of this particular surface, it appears as an inclined surface in the top view projections, so we need to evaluate the true shape of this T-shaped surface into this particular problem. Now let us read out the statement. The object shown in the figure has an inclined surface A observed in the top view, so we are required to draw the front view, the top view and the partial auxiliary view showing the true size and shape of the inclined surface available as surface A. So this is the face A. So this edge view, it is an inclined surface. Now in order to evaluate the true shape of this T-shaped surface over here, now we are going to draw an auxiliary vertical plane parallel to this inclined face A over here. Now once we draw an auxiliary plane parallel to this edge view of this T-shaped surface over here, then the projections of different points which are available on the edge view onto this auxiliary vertical plane, they will provide us with the true shape of this particular T-shaped section which is observed as an apparent view in the front view orthographic projection. So let us proceed with the evaluation of the true shape of this particular T-shaped surface. So first thing, we have got the front view projections. We have also got the top view projections. Now the XY reference line we have drawn over here, because we are going to obtain the true shape of this surface in the auxiliary elevation which will be drawn onto the auxiliary vertical plane, which will be parallel to this edge view of this T-shaped surface. Now we need to evaluate different points which are going to define this particular surface over there. Now we are required to establish the relationship between different points which are available onto this T-shaped surface and the corresponding edge view points which are lying over here onto this particular edge view, which happens to be an inclined surface over here. Now first thing, we have to mark different points which are going to define the shape of this particular apparent shape, that is the T-shaped surface over here, which is appearing in the front view orthographic projection. Now we can see that 8 points they will be required to identify different edges of this particular surface. So these points, they are 1 dash, it is this point, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash and 8 dash. So having identified and located these 8 points which are going to define this T-shaped apparent shape surface over here in the front view, now we have to project these points onto the edge view projections which are available with us in the top view projections over here. So we can check points 1 and 8, they will be projected at this particular point. Similarly points 7 and 6, they will be projected over here. Then the third projections will be corresponding to 4 and 5 points, that is 4 dash and 5 dash. So points 4 and 5, they will be projected at this position in the top view. Similarly the projectors corresponding to the points 2 dash and 3 dash. So they will be available over here at this particular position. So having obtained these 8 points on the edge view, now we have to draw an auxiliary vertical plane x1 y1 which happens to be parallel to this edge view, that is the face A. So edge view of the face A. Now once we draw this auxiliary vertical plane parallel to this inclined edge view of the surface over here, it is this surface. Now we need to draw the projectors from the various points over here onto this auxiliary plane. Now we have got these projectors which we have drawn in order to evaluate the true shape of this apparent shape surface over here. Now we know that this is the boundary. We can see this is the boundary which is available with us. So we are going to project this boundary over here while we are going to obtain the auxiliary elevation projections onto this particular AVP. Now in order to draw these auxiliary elevation projections, now we know that this distance happens to be 40 millimeter. So we can see that the height of the solid, it happens to be 40 millimeter. So we have marked this distance as 40 millimeter. Now why we have marked this distance? First of all, we have drawn this particular projection to begin with because many of the points, that is 1 dash, 2 dash, 8 dash, 7 dash, 4 dash, 3 dash. So all of these points, they have been located with respect to the top surface of this particular solid over here, which is represented in the front view orthographic projections over here. So we know the total distance or the height of the solid, it is equal to 40 millimeter. Now, and another thing we can see over here that this distance has been provided to me as 3 millimeter, and by symmetry even this distance, it is also equal to 3 millimeter. So now from this boundary point, because this is the boundary over here, so this boundary of this rectangle, because we are going to consider this rectangle, so it is this rectangle that we are going to focus upon. So this rectangle we are going to draw in the auxiliary elevation projection. So this distance happens to be 3 millimeter. Similarly, this distance also happens to be 3 millimeter. So it is this distance 3 millimeter that we have marked, and this distance, it is also equal to 3 millimeter. And then we know that this particular width, it is equal to 15 millimeter. That is the width of top surface of the T cross section. So this is the T cross section. So the top surface of the T cross section, it is having the width equal to 15 millimeter. And this 15 we have also divided further into 4 millimeter over here, 4 millimeter over here. So the remainder portion will be 7 millimeter. So this is 4 millimeter. This is also 4 millimeter, and this portion of the longer web over here, that is the vertical cross section of this T. So this width will be equal to 7 millimeter. Now I can mark these distances into this auxiliary elevation view, that is this distance corresponding to this part, it is equal to 4 millimeter. This is the width of the vertical portion of this T web over here, this is equal to 7 millimeter. And again you have 4 millimeter distance of this particular cross section over here. So these distances I have also marked corresponding to the width. So the dimensions along the width, they have been plotted in the auxiliary elevation view. Now I need to mark this distance, because usually what we are doing, we are marking the distance of points 1 dash and 2 dash from the XY reference plane. Now since the total height of the solid is given, this distance is equal to 9 millimeter. So we can have two versions over here. In first version, we can say we are going to mark 9 millimeter from this top surface of the solid, or else we can say that we are going to mark points 1 dash and 2 dash at a distance of 31 millimeter from the XY reference line. So either way we can mark the locations of the points 1 dash and 2 dash onto the auxiliary elevation view. Now we can see that we have marked a distance of 9 millimeter from the top surface. So which means that the distance of this projection line from the x1 y1 auxiliary vertical plane happens to be equal to 31 millimeter. So this distance we have marked as 31 millimeter. Okay, now once we mark this distance, now on the corresponding projector lines, so I need to evaluate projection line corresponding to point number 1. So this is my location of point number 1. From here, as I move along this projector line, so from this point I need to mark a distance of 31 millimeter in order to evaluate point 11 dash over here. So this is a distance of 31 millimeter. Similarly, where is my location of point 2 over here? So point 2 is located over here in the top view. So in the top view, this is my location of point 2. So as I move along this projector line, so from the auxiliary vertical plane x1 y1, again I will be marking a distance of 31 millimeter from the auxiliary vertical plane. So I will be obtaining the location of the point 21 dash over here. So the 2 points of this T-shaped apparent surface, they have been marked over here. Now next, this distance was 9 millimeter. Further, next distance is available with me as 8 distance. So this is the height of the upper part of the T cross section over here, right? So upper part of this T cross section, it is going to have the height equal to 8 millimeter. So I can mark this height 8. So now I can say if the total distance happens to be 30, so 30 minus 17, so this distance will be 23 millimeter, right? So either I have marked 40 minus 17 millimeter over here, or I can say this distance of these 4 points, 8 dash, 7 dash, 4 dash and 3 dash. So all of these 4 points, they are located at a distance of 23 millimeter from the auxiliary vertical plane. So since these 4 points, they happen to lie at a distance of 23 millimeter from the XY reference line, right, from the horizontal plane. Now once I have marked this particular point over here, again I can draw a projection line. The moment I draw this projection line, my points 81 dash, 71 dash, 41 dash and 31 dash, they will be located. Now I know that these are the 4 points corresponding to which I will be obtaining the auxiliary elevation point locations over here. So let me check it out. This is point 8 dash at a height of 23 millimeter above the horizontal plane. So as I move down onto this edge view, point number 8 lies here. So alongside this projector line, as I am going to reach this point, now I will be measuring a distance of 23 millimeter above the AVP x1 y1. So the moment I mark this distance as 23 millimeter, so my point number 81 dash will be obtained. Similarly, 7 dash. So as I move from front view to the top view, the location of 7 dash or 7 point will be located over here on the edge view. Now this is my projector line corresponding to the point 7. So from here, I'll be measuring distance of 23 millimeter. So once I reach this point, I will be obtaining the location of the point 71 dash over here. Similarly, point 4 dash is located at a distance of 23 millimeter from the ground or the XY reference line. Now corresponding to the point 4 dash, point 4 is located over here onto the edge view. Now alongside this projector line, as I move, now from here I need to measure a distance of 23 millimeter. So the moment I measure this distance 23 millimeter, point 41 dash can be located over here. And finally 3 dash is also located at a height of 23 millimeter from the ground or from the base. So corresponding to 3 dash, I have got the projection of the point 3 in the top view, that is on the edge view at this location. So this is the projector line corresponding to the point 3. So from here, again, as I measure a distance of 23 millimeter alongside this projector line, I obtain this point 31 dash over here. And finally, these are the 2 points 6 dash and 5 dash, which are available with us at a height of 8 millimeter from the XY reference line or the ground. Now this is the distance of these 2 points, 8 millimeter, 6 dash and 5 dash. Now as I move along this particular point 6 dash into the top view, so I locate the position of point 6 onto the edge view over here. Now from this projector line, that is corresponding to point 6 as I move in this direction. So from x1 y1 auxiliary vertical plane, I'll be marking a height of 8 millimeter alongside this projector line ahead of the plane, so that I will be able to locate this particular point which is named as 6 dash over here. This is 6 1 dash. Similarly, this is point 5 dash. So corresponding to this 5 dash, as I move into the plan view on the edge view, so this is the location of the point 5. So from this projector line, as I am moving, I have to move 8 millimeter ahead of this auxiliary vertical plane x1 y1 in order to locate the point 5 1 dash over here. Now this way, all the 8 points corresponding to this apparent shape, they have been located over here. Now since we have obtained the projections of all these 8 points from this particular edge view onto an auxiliary vertical plane which happens to be parallel to this edge view, so the shape of this particular surface which is shown over here as a shaded one, so this shape will be obtained as a true shape over here. So this is the true shape of the shaded portion which we had got into the orthographic front view projections over here. So this way we can obtain the true shape of an inclined surface of the solid. So this is the inclined surface of the solid which was representing the edge view corresponding to an apparent shape which was available in the front view projections of this particular solid. Here we have used the method of auxiliary planes to develop the true shape of an inclined surface of a solid, and these projections we can call as auxiliary elevation projections. Why? Because we have used the distances of the elevation from the XY reference plane in order to develop this particular true shape of this apparent shape of the surface of the solid. Now we can compare the true shape with the apparent shape which was available with us, and we'll find out that the size of the true shape, it happens to be bigger than the size of the apparent shape projections which were originally available with us in the front view projection. So I hope that through this discussion you would have developed proper understanding regarding the evaluation of the true shape of an inclined surface of the solid over here. So this was the inclined surface of the solid which was not available with us as a true shape in the original orthographic projection. So we were able to obtain only the apparent view projections in the orthographic projections. Now by using the auxiliary plane method, we have been able to derive the true shape of this inclined surface. So this is all for today. So we'll be continuing with few more illustrations in the coming lectures. Thank you very much. Thanks a lot.